Hi, and welcome to day 3 of our Intro to Environmental Data Science. Today we're going to finally work directly with some data, and we're going to work with some spatial data to start with. So if you don't know, there's this really cool website called earthengine.google.com/timelapse, or Google Earth Engine Timelapse. And what we can do with time-lapse is you can zoom around the world and sort of look at how things have changed throughout the period of the Landsat satellite record. So this is basically, there's been satellites taking good pictures of the Earth since 1984, and you can look at here in Dubai as they expand and build islands essentially, or you can watch a glacier retreat, and this is all using sort of just Landsat imagery. And what we're going to do in class today is sort of take some of this same time series that right here are displayed as images, and you can see this glacier retreat over time. And what we're going to do is actually analyze that data as a sort of time series data set. So in order to do that, we're going to focus on some disturbances a little closer to home. So we'll go to Cheeseman Lake in Colorado. And if you don't know about this, but this area had a massive fire in 2002. And so if we watch sort of just around the lake and pay attention to the bottom here, we'll start in 1984, and I'll just click through, or 1985 works fine. I'll just click through the years. So basically you can see over the years the lake expands and contracts a little bit, but for the most part it stays pretty constant. The vegetation is fairly constant. There's some clear cutting going on here and here, but really very little disturbance. And then all of a sudden in 2002 to 2003, essentially this huge area burned. And then if you track that after those years, basically it doesn't look like a forest sort of recovered. Oops, I went to 1984. So all the way up to 2018, it's still pretty brown. So how might we analyze that data? How might we look at time series of change in a forest that was burned and a forest that was unburned? Well, there's this really wonderful app made by folks from the Desert Research Center and Desert Research Institute and University of Idaho. And basically what you can do is you can draw little polygons like I've already done here. And what it'll do is take every time this landscape was imaged without clouds, it'll pull that data out and average it for this polygon. And what we're going to use here is a metric of greenness on the landscape called NDVI. So this is just the normalized difference vegetation index. And the higher the number, the greener the landscape is. So obviously in this area after 2003, it was pretty brown, but then we have a reference polygon in an area that was unburned down here in green. And what this app does is it sort of stacks from 1984 to 2019 every image possible. And it even generates a figure for you. So you can see what we would expect in the polygon that was unburned. You did have a slight drop in NDVI in that year, and that's because that year was a drought year, which is partially what caused the fire, but nothing like the drop in the NDVI in the blue area. And you can see the green area sort of recovers to normal relatively quickly after the drought, but the blue area is now in a sort of new lower NDVI mode. And this Earth Engine, this Climate Engine app allows you to download the data. So we can just go here and we can say download, and then we'll download it as a CSV. And all we have to remember is that polygon 1 is burned and polygon 2 is unburned. Now that we have our data downloaded, what we'll do is go to GitHub and make a new working repository for this analysis. So we'll call this Hayman fire. That was the name of the fire. DVI trace. Mostly just an example of data manipulation. I'll make this public. We'll initialize it with a README. We're going to create the repository. And now we just have this repository. We're going to clone or download it. I don't want that in my paper folder. I'm going to put it in my CSU teaching, environmental data science, Hayman example. Oh, oops. I actually just want it to be in this folder, so I'll just click on that. So now it's going to be a subdirectory, and it's going to be Hayman fire NDVI trace, which is great. So now it's going to copy it. It's going to open a new R environment, and we're going to have these files over here. And the typical way I organize this, and we'll go over this in class more, is I have a data file. And in that data folder, I'm going to put the thing I just downloaded. So if we go back here, we can do Hayman fire. This one. And we can just theoretically just plop this data into here. And now we have our data. I'm going to rename it because I don't want that one. And I'm just going to call it Hayman NDVI. Okay, so now we have the data that we needed to do the analysis in the correct folder. It's in this data folder. And now we want to sort of get to manipulating the data. And here, for most of you, it sounds like most of you have coded before, but coding directly in the console has some disadvantages because you can't actually sort of rerun and troubleshoot your scripts as much when you have a lot of different analyses you're doing. So instead of writing directly in here and trying to read data into the console, what we're going to do is do a file, new file, and then we'll create an R script. And all an R script does is it holds the sort of analysis, the different code that you'll write into one place. And so I'm going to save this as NDVI over time. And in this script, we can sort of do the analysis that we want to do. And if you did the sort of pre-class lecture before you watch this video, you know that the packages we're going to use are all in the tidyverse to do this analysis. So we'll go library tidyverse. And we can run that by holding command if you're on a Mac or control if you're on a PC, and it'll run that individual line. And then now we want to read in the data. So we'll do NDVI is the name of a data object, and we'll do read on, what is this called? Underline. Data / and then we can actually click directly on the data folder and remind ourselves of the name. So it's Hayman ndvi.csv. And CSV is just a comma separated value. It's a very typical way to store a data frame and share it across different groups or on the internet like we just did. And so now when I do control return or control enter on that, it's going to read that data in, and it's telling me that it read it in. There's one called date time. There's a column called date time, and there's one called NDVI Landsat for polygon 1, and another column called Landsat for polygon 2. And they're both doubles. And then it says the 533rd row didn't work. It failed to parse, so it couldn't understand the text in there. That's a warning you'll get fairly often, but let's go ahead and actually look at our data and see if the data sort of makes sense. So the first way I typically do this is doing a structure call. So I'm going to do structure NDVI and make sure that the structure is something I think that it should be. So there's a date time column, and then there's these two NDVI columns that have a really long name. And so we might want to change that. So that sort of tells us that indeed this sort of works, and then the NDVI is a numeric value, so I'm glad that it came down as a numeric, and that's what NUM here, where the cursor is, says. And date time was already read in as a date, which is great. That's what we want. So now we can look at this also in a traditional way that you might be used to looking at data in like Excel. And so here we have basically the date time, the NDVI value, and this really long column name, and the same thing for the other one. And you'll notice there's occasionally NAs, and those NAs are when it was too cloudy to get reliable data. So basically the data was cut out. Okay, so the first thing we want to do is that this column name, this first column, is really long and annoying. And here we can use a nice command called rename, and we'll start cleaning our data. A major way we're going to code in this class that you should be aware of is we're going to use pipes. So one way I could rename the data is I could make a new object, and I could say NDVI rename, and I could say rename as the name of the function, NDVI, and then I could say essentially, let's double check. I think this is polygon 1, and we'll go back to our thing and make sure polygon 1 was the one that was burned. So we'll do rename burned equals the second column, and unburned equals the third. And so now if we look at that same object, we have these really simple column names that say burned and unburned, which is what we want. And I'm just going to make sure I got that right. Polygon 1 was burned, polygon 2 was unburned. And that's the way we did it here. Cool. So that's one way you could do this. But you notice that if we do this, we're going to keep creating new object names. So that just kind of clutters your coding environment. So there's a way to avoid that, where what we can do is delete all this renaming here. And instead of using the object as a new name, we can actually just pipe the results of this line, so reading in the data, to the next line. And so what that's going to do is it's going to take the results of this and push it to this. And so it cuts out that step of needing to rename it. And it just really cleans up your code. So here we piped it. And now if we do ndvi, it's still going to give us that warning. That's okay. We sort of investigated it and the data looks okay. And now we look at just the one called ndvi, and it has the column names renamed. So that's one helpful thing we can do. Another is that we probably don't want any NAs in our data set because we want to do a one-to-one comparison. So when there's an NA in the unburned line, we probably want to drop also the burned line, if that makes sense. So what we can do is say filter, and we'll do is.na on burned. But what that's going to say, what is.na does is it asks, anytime there's an NA, give me a true false. And what the filter command says is if that's true, keep it, and if it's false, throw it away. And so in this case, it's going to keep all the NAs, which is the opposite of what we want to do. And there's a handy way to sort of inverse a filter like this, and that's just using exclamation point. So now I'm keeping all the things that are not NA in the burned column. And of course, we also want to keep all the things that are not NA in the unburned column. And so now what we're going to do is eliminate every time there is a NA in unburned, that data is going to be dropped. If there's an NA in burned, that data is going to be dropped. And if there's an NA in both, they're going to be dropped. So the comma here is an and. So basically, it has to both have NA. It'll only keep things that don't have an NA in the burned and the unburned. And the command we're using here is called filter. Okay, so now we'll filter that, and you can pay attention when you start to add these commands. Right now, this has 2,102 observations over in the far right, sort of by my face. And when we run this command, I would expect I'll drop some of those because I know there are NAs. So we can sort of watch, okay, wow, look, we lost almost 600 observations. And now we have what I would call a sort of cleaner data set. And we can look at it again. We can look at view ndvi. Okay, now we've dropped, there's no NAs indeed, which is great. That's what we want. Next, now that we have our clean data, we might want to organize it in a tidy way. So the way this is currently organized is what is called a wide data set. So we have a date, time, and then observations at site 1 and observations at site 2. If we wanted it to be in the official tidy way, then we will have just one date time column like we have here, and then we'll have a site column, and then we'll have the value of the ndvi. So this is just a much clearer way to code, and you'll see why as we go through the semester this sort of helps. So what I'm going to do is load in another package called tidyr. And what tidyr is going to do is going to reorganize this data for us. It's going to take it into these two columns and reorganize it so that they are stacked on top of each other, but with another column that identifies whether it was the burned or unburned site. So here we'll do ndvi long, because that's what's called a long data set. And we'll do what's called a gather. Gather is a command that does exactly that process I just described. And if you don't remember what a command does or how it works, you can always do question mark and then the name of the function. And so now we'll look in the bottom right. And so what it's saying is first I need the data set or the data frame or the tibble. So I'll do gather and then I'll do ndvi. And then it's asking what do I want the key name to be? So this is how it's going to fold the data. And so here we want the key to be called site. So we'll go key equals site. And then value we want just to be named ndvi because that is the value that we're interested in. And so here we'll do a gather now. And now we have this long data set, and let's take a look at how it did it. And I can already tell it did it wrong. And so it didn't know that I wanted to keep the date time column separate. So how do we fix that? Okay, well, let's investigate the gather command. And we can look down here for examples. And over here, they're doing something that we want ourselves to do, which is they're keeping the species column. And here they have a negative symbol. And so what we'll do is we'll do comma and then negative date time. And what that does, or a minus symbol date time. And what that does is says, hey, when you gather this, keep the date time column separate. And so now let's rerun that command. And then we'll do head, which shows the first several lines, and now we have what we want. We have date time, we have a site column, and an ndvi column. So now that this is in a long data format, we can actually just start to plot the data. So we're finally going to reproduce the graph that Earth Engine already made for us. Here we're going to use ggplot, which comes pre-packaged with tidyverse. So again, let's just sort of investigate what ggplot wants. Okay, so it wants ggplot, and then it wants the data set, so ndvi long. And then you use this thing called aesthetics. And so the x-axis here, we want to be date time. So we'll do date time there. And then the y-axis, we want to be ndvi. We want this to be colored by site. And then we want to plot it as points, maybe. Okay, and so now we have our plot in the bottom right. You can see that points actually is sort of a little bit harder to track. So maybe in addition to points, we want to do a geom line so that we can see a trace as it goes through time. And so now you'll get to see sort of this trace. One thing about using these points is that they are filled in, so they kind of block each other out. So maybe we can do shape equals 1, I think, and that'll be a hollow circle. You can always look up what shape numbers, and that's a little bit easier to trace. I personally strongly dislike the gridded gray background, so I'm going to load another package called library gg themes. And at the very end of this, I'm going to say theme is few, and that's just one of the simplest themes you can do, and it just sort of changes the color. I also dislike the color that comes with ggplot, so I'm going to do scale color few. I'm just going to copy that, and this changes the color. I think it's a little bit easier to see. And then finally, that legend is sitting out on the outside, and we don't want that, so we'll do theme legend position equals C, and then this is just a legend position as where you want it in the graph. So we're going to want it on the X of 0.2, so 20% in, and then on the Y also probably about 0.2 or 0.3. So I'll do C equals 0.2, 0.3. And then we'll run that. And I spelled it wrong. So now that moves in there, and you can see the graph a little bit more clear. Okay, so now we have our plot. If you look at this data, though, it's actually a little over-dense to look at such a long time series. So we have almost 1,500 observations over time, but maybe all we really care about is sort of annual changes. So how might we just sort of summarize this data to just get an annual variation? Well, so we can do ndvi annual. And we're going to need to load another package to do this. This is a package that manages date time really well. It's called lubridate. And so now what we want to do is we want to take ndvi long. We want to make a new column called year. So we just want to summarize this data set by year. So year is going to be the name of the column, and it also happens to be the name of the function that can extract just the year from a date time object. So now we have this thing called NDVI annual, and if we do head NDVI annual, we'll have a new column called year right here. And then to get the sort of, let's say we want the mean NDVI per year, what we're going to do is do a group by, and we're going to group by both the site and the year. And then we're going to summarize, and we're going to say mean NDVI equals mean of the NDVI. And what that does, if you're looking at NDVI annual over here, right now it has 3,000 observations. Once I summarize, it's going to collapse the data per year per site and just take the mean of all the data that fits that category. And so it should make it much shorter. So now we only have 72 observations. And again, we can sort of recreate the plot from up here. Instead of plotting by date time now, though, we're going to plot by year. And we're going to change this to NDVI annual. And I didn't call it NDVI. I called it mean NDVI. So I need to fix that. And so now we get an annual trend. And here it's a lot easier to see the effect of the burn. So that's sort of another way you can organize this data. One other thing I want to sort of just briefly mention is that in your code, right now I'm coding fast and trying to give examples, but you always want to comment. So you want to say like here, making an annual plot, summarizing the data by year. So as you're going through your code, you want to make these comments not only for if anyone else is going to collaborate with you, but you really want to do it just for yourself, because when you refer back to your code in the future, it's going to be really helpful if you have these comments. So just plotting all the data. And you can always code sort of the way I just did, where you code and just visualize and check it out, and then comment once you know that the code is going to sort of be settled. So converting from wide to long data and oh, my computer does that occasionally, not sure why. Okay, so now that we've done that, we can sort of do a final thing, which is maybe we want to sort of check out the seasonality of this. Not check out the seasonality, but now here we're taking the NDVI and we're including winter months, which doesn't make the most amount of sense. So we can do another mutate to sort of clean this data up a little bit. So we'll do month equals month date time. So what this is going to do is extract just the month from that date time object. And then what we'll do is we'll filter and we'll keep months, only the months that are in May, June, July, August, and September. So we're just trying to keep the growing season months essentially. And we'll just make sure that, when we're averaging NDVI, it makes sense only in Colorado, where there's a big snowy season, to average over the sort of summer months. So now when we do this, we should we'll get the same shape of data, but the plots should vary just slightly. So if you look, indeed, when we do just summer months, the plots do vary slightly. And here you can see that there's basically always been a difference between the burned and unburned sites, which is fairly obvious from the map as well. If we go back here, this area is sort of a little bit further away and is in a more like bisected, steeper topography versus this sort of larger flat area. So that's basically all I wanted to get through today. We'll go over some of these ideas in class, but again, now that we've sort of finished a series of tasks, what we'll do is do a commit. And here I see something that should scare me. I don't want to push up data to GitHub ever. It can really mess up your GitHub account. So what I'm going to do is actually exit out of this, because I saw that mistake I made. And I'm going to go back into Hayman Fire, and then I'm going to go into this file called gitignore. And what gitignore does is it tells you, tells your computer that you don't want to push data up to GitHub. So here we have all these different things that it already knows I don't want to push up to GitHub. And here I'm just going to say anything in the data folder, don't push up to GitHub. So now we'll go back and try commit. And if we succeeded, that data folder is gone now. So now all we have is we've updated our git ignore because we added this \data. And we've updated the R project information, which is just telling us what my presets are. Oops. And then we want to update our script, which is all brand new. And then we want to just say we analyzed burned versus unburned watersheds. They're not really watersheds, sites in the Hayman fire. Then I'm going to commit that. That looks good. And then I'm going to push it. And now if we go back here and reload, that R script we just wrote is now up here. Cool. So that's all for today.